Hello everyone, welcome once again. In the first two topics, we just had an idea of the complete arrangement of electrons. Somewhere already we have correlated orbit, suborbit, and orbitals with N, L, Ml. But today, the actual correlation of these values N, L, and Ml will be discussed as one of the most important part in quantum numbers. There are 7 to 8 good questions that have been provided to me in the comment box, and after this video and the test, a different short video will be uploaded where all these questions will be discussed. So today our prime focus would be quantum numbers. So first of all, very clearly understand in a single word, quantum number is an address. But over here, going into the subject and speaking technically, we can always assume it as complete information of an electron. If I want to exactly know the location of an electron and I am aware regarding the values of N, L, Ml and Ms for that particular electron, I am quite sure that I can locate the electron at an exact point. So first of all, just for the purpose of revision, let us just revise once the N, L, Ml and Ms. Over here, the N value, that is also called the principal quantum number, always indicates the electron shell and most probable distance of an electron from the nuclei can be predicted just by knowing the value of principal quantum number. Over here, this quanta suggest energy or energy packets, and each electron as is moving either clockwise or anti-clockwise has its own energy, and that is distributed among these 4 quantum numbers. So friends, when we will say that the most probable distance of an electron from a nuclei, we mean to say that if this is the nuclei and one electron is over here, second electron is over here, so the electrons are not just like that. They will be moving in some designated circular path, and that path is now known as orbit. And this orbit, because of this statement of most probable distance of electron from nuclei, can directly be correlated as principal quantum number, and this was the reason why earlier itself we have designated N to an orbit, which fundamentally is the path where an electron is revolving around the nuclei, and over here that electron position from the nuclei is considered as the most probable distance of an electron. Henceforth we can correlate principal quantum number as N, and for our understanding and for appearing in the competitive exams, orbit as N. Moving towards L, it is angular moment quantum number. Generally it is said that shape of the orbitals are defined by angular moment quantum number. It is right, but helps in determining the specific subshell. It always helps in determining the specific subshell, and we have got it when we determined S, P, D and F. Now moving in ML, that is the magnetic quantum number. It always helps us in determining two aspects. Number one, number of orbital, and number two, their orientation in a subshell. Now here we can easily make a difference between a suborbit and this orbital. Sometimes, pardon me, sometimes there is a confusion between a suborbit, that is a subshell, and a orbital. But there is nothing like confusion. Why I would tell? When we only assume by writing p. Nevertheless, I have heard people telling it p orbital. Okay, no problem. They say it p orbital because this p falling under the category of L, that is angular moment quantum number, helps in determining the shape of an orbital. But this p is correlated with a suborbit. Remember this very well. P helps us in defining the shape, that is, the p suborbit will have orbitals having a dumbbell shape. But in what direction would be that dumbbell shape? Whether on the x-axis, whether on the y-axis, whether on the z-axis, that can only be proved when you have the values of ml, that is the orientation in a subshell, and then only we can get a conclusion that px, py, pz. So this is that very basic difference between a suborbit, subshell, and orbital. So keep this thing in mind. And ms, that is the spin quantum number, it always helps us in getting the direction of an electron spin, whether clock or anti-clock. And remember, this value ms, popularly known as spin quantum number, is independent of NLML. It is directly obtained by observing an electron and its spin, irrespective of the value of principal quantum number, angular moment quantum number, and magnetic quantum number. So remember this thing, and then only we would move ahead. Friends, moving ahead in this topic, let us now try to examine few examples or numericals that are very much important while going with quantum numbers, and what kind of examples are actually there when it comes to quantum numbers. So remember very well that n nevertheless is principal quantum number, but it helps in determining orbit or shell. Going a step ahead with L, let it be this angular moment quantum number, but it helps in determining a suborbit or subshell. Nevertheless, people say that shape of an orbitals can be determined. Truly right. Coming to ML, that is magnetic quantum number, helps exactly in determining the orbital and direction in plane or axis. When I say axis, I always mean to say px, py, pz. But when I say plane, apart from that, we can add dxy, dyz, dzx. The reason I have written it directly is we are quite aware of such things. And coming to ms, it is helping us in determining the spin quantum number, that is the spin of an electron, whether plus 1/2 or minus 1/2. Now, when we are discussing this quantum number topic, how could numericals be helpful to us, whether it is competitive exam or whether it is understanding an electron? So my prime focus today in the rest of this lecture would be numericals or examples. I'm just starting with a very simple example and then we will move ahead. I'm just taking example of hydrogen 1H, and when I write the electronic configuration of hydrogen, it is 1s1. Now if we are asked to write the all four values of the electron or an electron present in a hydrogen atom, how would we write? First of all, we should know that N, L, Ml and Ms are the required values to be produced. So when we write 1s1, we should always draw one square indicating an orbital, because we know that for S, P, D and F suborbits there are respectively 1, 3, 5 and 7 orbitals. So as it was S over here, I have just made an orbital. Now this value 1 always helps us by suggesting that it is the first orbit. So if this is our nuclei, the electron what we are discussing as of now is in the first orbit itself. So this one has helped us to locate the energy level where our electron is. So we can say n is equal to 1 and you could write it as first orbit. Going for L, very well, this value S suggests very clearly that L is S, the suborbit S, the subshell S, but its value that is 0. Why? We have already designated small l to be the symbol for subshell or suborbit, and it has corresponding values 0, 1, 2, 3 depending upon the formula L is equal to n minus 1. This is how it works. ML, always remember we have discussed ML to be minus L to plus L. If we are talking for this S subshell, the orbitals, S is having a value 0, so it will be minus 0 to plus 0, so only 1. So the value for this square bracket will be 0. Remember very well what I am speaking. The value for the square box, is 0, because it is just one orbital in quantity and its value is 0. And last, we need to put only one electron. So friends, remember very well, in no book it is written that the first electron should be clock or should be anti-clock. The first electron or the electron in hydrogen can be clock or can be anti-clock, can be plus half corresponding to clockwise rotation, can be minus half corresponding to anti-clockwise rotation. But for the purpose of correctness, for the purpose of competitive exams, for the purpose of scoring, we will always assume that the first electron entering into any orbitals in a suborbit will have a clockwise spin. And if so, the first electron with the clockwise spin, we will consider this and not this. I have very clearly stated nowhere it is written, but to keep a uniqueness for all of us, we will always mention first electron as clockwise and the second as anti-clockwise, and therefore its value will be plus 1/2. So now our answer will be n is equal to 1, L is equal to 0, ML is equal to 0, and MS is equal to plus 1/2. And remember friends, this order has to be kept same. So sometimes even if you do not write all these things and just write 1, 0, 0 and plus 1/2, a person, whether a teacher or a student who is quite aware of the subject, will always consider this as n, that is principal quantum number, and a reference to orbit, 0, that is angular moment quantum number, and reference to suborbit. Nevertheless, it helps in determining the shape of an orbital. 0, that is magnetic quantum number, directly indicating orbital and its directional property, and plus 1/2 or minus 1/2, whatever it be, indicating the spin of an electron represented by ms. So friends, this is very important. I hope you are getting what we are discussing. Now let us move ahead with few good questions or good quality examples. I am just going to add now fluorine over here, and see, we will just add few questions to it. Fluorine 9 having electronic configuration 1s2, 2s2, 2p5 is given to us. Now first of all, let us explain it in the form of orbitals and write it like this. The first electron will always be placed in 1s. Now you cannot directly jump to 2s. You need to first complete this 1s energy level. So the second electron, now coming to 2s, the third electron, 2s2, the fourth. Now comes this rule, that is 5th, 6th and 7th. Once all the orbitals in a subshell are half filled, then and then only we could go for pairing. So the 8th electron and the 9th electron. So for me this is important, as we have decided, or rather I have told you, that always keep the first entering electron in an orbital as plus half. To make least confusions, I will always say plus half indicated by a upper headed arrow. I will always consider this as my first electron, this as my second, third, fourth. Similarly, 5th, 6th, 7th, 8th and 9th electron. Why I did such a thing? Sometimes we come up with the question that write set of quantum number for the unpaired electron of fluorine atom. The unpaired electron of fluorine atom. So when you will look into this, you can observe this as the only unpaired electron of fluorine atom. So now we need to describe the N, L, ML and MS for it. Always first complete the MS value, and as decided, the upper headed arrow as plus half and the bottom headed arrow as minus half, here you could see that it is the green colored upper headed arrow. So I will just mention it as plus half. Then see this number, as it is 2, it is always the principal quantum number, and it indicates that we are talking of an electron in fluorine atom which is in the second orbit, L, as it is the subshell P, we very well know that SPDF 0123, so it is 1, and we can write somewhere that P corresponds to 1. Now comes ML, that is the magnetic quantum number. Friends, always remember, when it is P or D or F suborbit or subshell, the way to determine the value for P, D or F subshell containing orbitals is always with the formula minus L to plus L. So for P set of suborbit, when someone says that I want to determine the value for each orbital, we should first know the value of L for P, and it is 1. So I'll just write minus 1 to plus 1, minus 1, 0, plus 1. And always remember that we will always move from minus to 0 to plus. So it will be minus 1, 0, plus 1. Now I will just take a minute in between, as I got a question yesterday that, sir, are all these 3 orbitals in a suborbit equal? Please explain. I will explain it in 2 different ways. Generally, when you write them or draw them like this, definitely it seems to have equal energy. But when they are degenerated, their energy will change. And definitely, as I told you in the initial minutes of this lecture, I am going to take a separate lecture on questions. But this is the way we could answer. So over here, minus 1, 0 and plus 1 are the corresponding values. Similarly, while coming to D, it is minus 2 to plus 2. So it will be minus 2, minus 1, 0, plus 1 and plus 2. And coming to F, it will be minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So this is the way it works, friends. So over here in the P, now we can have an idea that this is minus 1, this is 0 and this is plus 1. So this corresponds to plus 1. So I'll write it plus 1. So these are the set of quantum numbers for the last electron of fluorine. Pardon, the unpaired electron of fluorine, not the last electron. The last would be this, 9th. I am talking about the 7th electron of fluorine. That is the unpaired electron of fluorine. Now, I hope you are getting it. Moving to the second type of question in this. Get the set of quantum number for last electron of calcium. We very well know regarding calcium, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But we can write argon 4s2 because these are the inner shell electrons. So I will just indicate the 4s energy level with the first electron and the last electron. Remember, there are 18 odd electrons that are settled over here. that is 1s2, 2s2, 2p6, 3s2, 3p6. According to us, this is the 19th and this is the 20th electron. So this will be the last electron, and therefore for that n is equal to 4. L corresponds to S, and S is designated by a value 0. ml. Remember very well that if L is 0, ml will always be 0. If L is 0, ml will always be 0. So this is again 0, and ms, that is minus 1/2, because it is anti-clock. So this is how the very simple type of question work for it. Moving ahead with another type of question in this same category of quantum numbers. Sometimes they give us the set of quantum numbers and ask us to find the element, corresponding element. See how. If n is equal to 3, L is equal to 1, ml is equal to 0, and ms is equal to minus 1/2. If the above information is for the last electron of an atom, what is that atom? Now, this information is for the last electron of an atom. What is that atom? So, be calm and first of all find out n. N is 3. So it is very clear that 1s2, 2s2, 2p6 is done, because we are in the third orbit. It is only possible when the first and second orbit are completely filled. Otherwise, you cannot go for the third orbit with reference to Aufbau. Friends, over here, I would like to make a clarity. Might be in the lecture 1 or lecture 2. Somewhere I might have pronounced it as a person. If so, it was my mistake, or whatever you consider. It is a word for rearrangement given by some scientist. So, according to the Aufbau principle, as we are in the n equal to 3 orbit, it is very clear that we are done with 1s2, 2s2, 2p6, and this represents neon. So we are still finding the atom, but we will write neon first. And we are in the L equal to 1. So p suborbit, it means S is completely filled. So 3s2. So we are in the 3p, that is confirmed. Yes, it is confirmed. We are talking of ml0. Now this is one of the best thing to learn. See how. The first will be always minus 1. The second will be always 0, and the third will be always, plus 1. Where are we getting these from? These are the ml values which can be obtained by the formula minus L2 plus L, and for P, the value of L is equal to 1. Now you are talking of ml is equal to 0. Friends, there are two probability. Number 1, you can only go to 0 when you first fill an electron in minus 1. So this is minus 1, the first electron. This is the second electron. The third electron. Let me do one thing. Third electron. The fourth electron. the fifth electron. Now, why did I do so? Always remember, when you are done with N and L, before justifying ML, keep an eye on MS. Just now we said that no one has told any time that plus half is clock, minus half is anti-clock. You should always keep plus half first and then minus half. No one has told. But for our observation and what we have learned up to now, we have always observed that upper headed arrow is placed first and it is designated as plus half. If such is the case and over here the value is minus half, means it might be a lower headed arrow and might be anti-clockwise. And as of now, as we said, that first we put clockwise arrow and then we put minus, that is anti-clock. So in this p suborbit with three different orbitals, this is the first one, so it would be 3p1, that is the 13th electron, 3p2, that is the 14th electron, 3p3, that is the 15th electron, 3p4, that is the 16th electron, and 3p5, that is the 17th electron. So if we always keep in mind that ms minus half will come in the second round, not in the first round. First three will always be plus half, then minus half. Then obviously ml is 0. So it will be this one, because we know this value 0 for the middle orbital. And if it is 0, the second is minus half. Then why I rubbed that one? Because I have already mentioned in the question, last electron. So if such is the case, you have 10 electrons, 12, 13, 14, 15, 16 and 17. So the last electron is 17. And henceforth we were talking about chlorine. But friends, there is an ambiguity, a confusion, that sir, you yourself told that no one has written in any book that a lower headed arrow comes second and upper headed arrow comes first. If I, being a learner in chemistry, in the set of this subshell, put a lower headed arrow first and then go for a upper headed arrow, then as I have put the lower headed arrow first, this will be my minus half. And then if I think again, this will be the 13th, this will be the 14th, this will be the 15th, 16th and 17th. And according to that, the 14th has to be this information. Yes, you are absolutely right. If we consider generally, we can have two answers, 14 silicon or 17 chlorine. If in a question paper you observe a thing like this, definitely you are in a win-win situation. Both answers has to be correct on the basis of chemistry. But examiners always keep one of these two options open, and if they are thinking the way we are thinking, that the upper headed arrow should be first in an orbital, the lower headed arrow should be second in an orbital, then chlorine has to be the answer. And why I am saying it with this confidence, out of every 10 books, in 9 chlorine will be the right answer. That is, the method will be with respect to chlorine as an answer. And in 9 out of every 10 question paper, chlorine will be the answer. I want your feedback on this, especially if you have not understood. I can even go in much details still. Let us just repeat it with another example, that if n is equal to 2, L is equal to 1, Ml is equal to plus 1. If Ms is plus half, what is the electron and atom we are talking about? If Ms is equal to minus half, what is the electron and atom we are talking about? Both the questions. These three will remain constant. As it is 2, it is very clear that we are talking of the second orbit. As L is equal to 1, it is 2p. Now when it is 2p, you have 3 set of orbitals corresponding -1, 0 and +1. See, let it be clock, anti-clock, but the order of input of electron is fixed. 5th electron, 6th electron, 7th electron. I am still not telling whether to put upper headed arrow or a lower headed arrow. But 5th has to be placed here, 6th has to be placed here, 7 has to be placed here. 8, 9 and 10. So it is very clear that as you are talking of +1, it might be 7th or it might be 10th. Now if you go according to what Beepser's formula is, always the first electron has to be +½ then 7th will be my +½ and 10th will be my -½ and therefore nitrogen I am talking about if I am saying +½ if I am talking about -½ I am talking for neon. Such simple is this. But no, I want to have a fight with you, sir. Let me write -½ first and +½ next. Then no worries. Write accordingly. So if you go that way, this will become nitrogen and this will become neon. But keep in mind that as I am discussing on this open platform and more than 1,000 viewers keep on interacting by watching this session, I will think twice or thrice before giving anything. So if you believe in this ratio of book and question papers, always remember that in an orbital, whether it is for S, P, D and F, in any orbitals, in any subshell, the first electron entering should be upper headed +½ and the second electron entering should be lower headed -½ with respect to question papers, scoring marks and finding out the correct atom. So over here I can write nitrogen for +½ neon for -½ and vice versa if you think something different, which is correct. So friends, this is how quantum numbers is helping us determining each and everything. Remember some few important things. Sometimes a very simple question has erupted every second year, at least in the SLET exams, every third time in the NET exams, that which of the following is not the correct set of quantum numbers. They will write N, L, ML and MS. Nevertheless, you very well know +½ -½ +½ -½ for MS only +½ and -½ are possible. So always while solving these type of questions, keep your eye on MS. If you find anything other than this, there itself you can say that that line is wrong. Second thing, principal quantum number that determines the orbit. I had an email that, sir, why are you correlating N with an orbit? Let me answer it today. Nevertheless, I am going to record a separate thing. But I am always trying to correlate orbit with this principal quantum number because apart from the things that are written in book, see, N always starts from 1 and an orbit always starts from 1. 1, 2, 3, first orbit, second orbit. We never say 0th orbit. We always say first orbit. So N is equal to 1. So if over here it is 2, 3, 4 and 1. Coming to L, always remember you had a formula L is equal to N minus 1. If you remember, this is the formula. How many suborbit in an orbit? Lecture number 1. How many suborbit in an orbit? L is equal to N minus 1. Which orbit? Which suborbit? L is equal to N minus 1 up to, yeah, that way. So keeping that thing in mind, we will over here mention few very important things. That is, when I say n is equal to 2, always my L has to be 1 lesser. If my n is 2, my L cannot be greater than 1. My L cannot be greater than 1. So I am allowed to either put a 0 over here or put a 1. But if I put 2 over here, I am gone. Always remember, L is never equal to n in quantum numbers. L is never equal to n in quantum numbers. So over here 2, over here 3, and over here 1. Just going a step ahead, here itself few learners will say, sir, L and n are equal, and I'll also say that of these 4, this will not be the possible set of quantum numbers, and you are right. And now ML, remember very shortly that the value of L written just by adding a negative and a positive side to it, it becomes the range of ML. So as it is here 1, corresponding range of ML will be -1 to +1. You can write anything between -1, 0 and +1. So if I mention +1, yes, I am right. If I mention -2, yes, I am right. If I mention +3, yes, I am right. But when I mention over here +2, no need, because n is equal to L. So when n is equal to L, no need to go for the third one. So this is one of the very important set of quantum numbers, and from this you can very well say that, sir, fourth set is the incorrect one. So this is how, friends, we work when it is quantum numbers. I would just mention again few very IMP points that are to be kept in mind while solving these questions of quantum numbers. Number 1, n is equal to 1, 2, 3, 4 up to n. So if you find over here a value lesser than 1, just eliminate and get your 4 mark for your competitive exam. MS will always be +1/2 or -1/2. Anything other than +1/2 and -1/2 over here, +4 marks. Third important, very important thing. Value of L will be always 1 less than n. So this formula is very important. If I say that I am talking of the 4th quantum orbit, 4th quantum shell, n is equal to 4, sir, you can write L up to 3, anything you want in your mind. But sir, do not write negative values. So L is equal to n minus 1. No negative value allowed. So this is how it works, friends. And last but important thing, that ML will always be -L2 plus L. So if I have this as 2, automatic my range becomes -2 to +2. No need to think anything else. So friends, this is how quantum numbers can be solved. While I am recording for all my viewers and subscribers and well-wishers, I am rubbing it quickly because you can pause this video and write. If it was a live session, I always wait for 30 to 60 seconds after the board work. Let us take one more example and discuss it. Sometimes it is written that for L is equal to 2, Which of the following is not the correct value of ml? Which of the following is not the correct value of ml? We should know that when L is equal to 2, ml is equal to minus L, 2 plus L. Therefore, minus 2, 2 plus 2, and that is minus 2, minus 1, 0, plus 1 and plus 2. So, if from the options A, B, C, D in one of the competitive exams, if some great fellow writes plus 3, 4 marks. So this is how it works. Now I will write a statement and justify one of the question. Sir, why are you writing S alone sometimes as an suborbit, sometimes as an orbital? Why did you say that L determines a subshell and ML determines an orbital? I'll prove it today. There was a question 3 or 4 years back in one of the NTA based exam, and I cannot say much, but how much I am associated with this NGO DIPAM Foundation, and to those small kids who come to us and learn the concepts. The question was, what is the number of electron in p orbital? See, this was the question, and the answer to this had 4 options: 6 electrons, 2 electrons, 3 electrons, and 10 electrons. Now, generally, up to what I know, for every 100 participants in that exam, 40% attempted the answer 6. Few of you might have got the answer in your notes now itself, and this was the wrong answer. What they assumed, that sir has taught us S, P, D and F. Sir taught us like this, that this L is equal to 0, L is equal to 1, L is equal to 2 and L is equal to 3, and this corresponds to S, this corresponds to P, this corresponds to D and this corresponds to F. Yes, you are absolutely right, but this P is this whole region I am talking about. And that total set of things can never be called an orbital. Remember from today, with respect to this question asked in one of the competitive exams where this is a good authority for the answer keys, and they considered the complete set as a suborbit or a subshell, and therefore this answer was given wrong, because if they would have considered orbital as suborbit or subshell, then it would have been 6. But friends, remember very well that when I use this word orbital, I am just representing this one single box. It can be any random box in this series, but at a time only one box, at a time only one orbital, and an orbital can maximum accommodate only 2 electrons. Pardon me, I will not break the rules. I will first fill half and then only I will fill 2 electrons. So friends, always remember, whatever question they make to get you -1 mark in your competitive exam, if you find an orbital word over here, don't get confused with the suborbit and subshell. Your answer will always be 2 electrons. This is where I wanted you to focus. Yes, if they would have written P suborbit, I would have supported these 40%. and your answer has to be 6, because now, sir, you are talking of this complete thing and I have to obey you with the answer 6. So keep your eyes and mind open, and as of now, on the basis of definitely different questions, I'll just get out of the track for a minute. I had a mail that, sir, suggest us some reference books from where you are teaching. Definitely I use several books, but I believe also to have an equal weightage on the question papers that are coming. And this concept, I got it very clear from a question paper I would address over here regarding this orbital and orbit. So I always believe N to be orbit, L to be suborbit or subshell, and ML to be orbitals. And if you have a different theory written somewhere where I am incorrect and I need to correct myself, you can please send me those. We will sit together and get an idea out of it, because it is a two-way learning process always for me, whether I am in my institute or whether I am with you on this channel. Moving ahead with last question of this video, and this will make many things clear for quantum numbers. From all these questions, sometimes in quantum numbers they say that for bromine 35, what is the total number of electrons having L equal to 0? See what happens. Bromine 35, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Check it whether it is 35 or not. 10, 20, 30 and 35. What is the question? L is equal to 0. L corresponds to suborbit, subshell, and 0 corresponds to S, suborbit. So I am only interested in S, because only this S will have L value 0. And now I will sum up these electrons. While summing up this electron, I will end up with 8. So my answer will be 8. Now, instead of this, if the great fellow tells us L is equal to 1, ML is equal to 0. Now comes the real output of what we are discussing since morning. See, this is what L is equal to 1, because this represents P subshell, and ML is equal to 0, so I will be always talking of this one, because this is -1, 0 and +1. So for every P, now you will be required to draw these things, and then only you can answer. See what will happen. As it is 6, few of you might say, sir, no need to draw, 6 means completely filled. Yes, I know, but what about my UG students? I should have a clear idea for them. They are going to learn maximum. 2 electrons with L is equal to 1 and ML is equal to 0. Definitely yes. Again over here, the same theory. So 2 plus 2, 4. Don't get confused. Over here, 1, 2, 3, 4, 5. So again, over here, 2 electrons. Someone will say, sir, let me oppose you. I am going to have a fight with you. Let me put reverse. No worries. This question will be justifying both of us. Again 2. So whether you write a upper headed series or a lower headed series, the total number of electrons will be 2 plus 2 plus 2, and my answer will be 6. So friends, this is what, according to me, quantum numbers is all about. The numericals are more important in quantum numbers rather than thinking more about where to put N, L, ML and MS. In my words, what I have understood, in these many years. N, a orbit or a shell. L, suborbit or a subshell. Ml, orbital. And ms, electrons. For me, in any damn orbital of any damn subshell, I'll always put the first electron as an upper headed arrow, and I will always call it plus half. For the set of orbitals present in a subshell or a suborbit, whether it is p, d or f, I will always go from left to right, from negative to positive. For me, ms cannot be anything else than plus half or minus half. N will always start from 1 and L will always start from n minus 1. So friends, once again, thank you. Your feedback are very important to me. Your questions are very important to me, as I wait for the whole day to complete, and the very next morning I go with the recording, so that I can address maximum of questions. I can make you understand the concepts of a new topic based on your feedbacks from the last lecture. So keep watching, keep sending your feedbacks and your suggestions. They mean a lot to me. And remember, I will come up with a separate small talk in a span of next 48 hours, where I'll be solving all the questions and queries related to lecture 1, lecture 2 and lecture 3. So if you haven't yet posted your query, if at all you have, post it. Once again, revise all the 3 talks, because in the 4th talk we will be starting directly now with the term symbols. Thank you.